In this table from a study by McKinsey in 2015, we can see the ranking of economic activity sectors in terms of digitalization. It is an overall ranking. It is an overall ranking, a global ranking. And clearly, we can see that ICT and finance sectors are the best ranked. However, construction and agriculture are in the bottom of the ranking. Indeed, these two sectors of activity are the heart of our training today. This is an example relating to an espresso coffee machine, which costs $140. But what is interesting is when you open the box, you will find a user manual and an assembly and maintenance technical sheet. The counter example is the Hassan Mosque in Casablanca, which was built in the early 19th and which represents the third largest mosque in the world. It is a mosque with cost $318 million. But what is striking, it is this work does not have any as-built plan. Another relevant and striking example is the 2D representation of the building, which is indeed just a symbol that allows construction professionals such as architects, civil engineers, and surveyors. However, a 3D model allows you to better understand the building for professionals, non-professionals, and even for a child. Moreover, the construction trades were in the vertical perspective. Indeed, the communication between the architect, structural technician, surveyors, and the construction companies have always been complicated to manage. So, the collaboration has been very limited. Of all the above, the construction sector needed a unifying tool that allows good collaboration between the various stakeholders. Now, I present you what is not BIM, what is not building information modeling. BIM is not a software. Indeed, many professionals are convinced that BIM is software. However, software is only a tool that allows you to visualize, stimulate clashes, measure, build before building, creating ultra-realistic environments, etc. The truth is that the software has an important role, but it alone does not constitute the whole BIM process. We have here many examples from Revit, Autodesk, Tekla, Bentley, or many more, but it is important to know that software is not a BIM. BIM is not a fad. Also, BIM is not a 3D plan. Indeed, the 3D plan or the BIM model must have informative elements which make it possible to answer questions for a geometrical and alphanumeric order. The professionals who have already worked with the GIS, Geographic Information System, understand well this thing. And finally, BIM is not a fad. It is not a fleeting process because it will become a norm. The client capitalize a financial gain behind the adoption of BIM. So it is the customer who decide on the use of this process. BIM is in the process for operation and maintenance reasons. So it is not a luxury authorized by companies or design office looking to digitize their process. And now, the definition of the BIM. For BIM, three definitions seems to stand out. If the B for this acronym is building and the I, information, leave no room for interpretation, the M in the acronym can mean modeling and management, depending on the case. Model, it involves the digital file of the building. Modeling refers to the work process facilitating the exchange between the various stakeholders and the construction of data. And finally, management refers to project management. Another BIM definition, it is a project management process based on the use of an intelligent 3D digital model. It is a working model or working method that is requested by the project owner, implemented by the project owner also, and shared by all the project stakeholders with different levels of use for each. The objective can be very varied, financial, optimization, exploitation, and many more. BIM is a process that brings together several stakeholders around a common project, defining the responsibilities, periods, and limits of intervention of each one. This process is effectively associated with a digital model that is made up of objects. Each object is defined by an infinity of characteristics, whether technical, financial, semantic, or behavioral Please turn off your mic, please. Thank you. Each object of a digital model therefore carries data that characterizes it, which in fact confers intelligence of the model and makes it possible to qualify it as an avatar of construction. Building information modeling is not about buildings only. BIM is also about infrastructure. Indeed, and thanks to the new exchange formats, and in particular the EFC5, many improvements have been made for the realization of digital model-oriented BIM of the infrastructure. Here we have a model like your subject, the dam. We can modelize the dam in 3D and also have many information and simulate many dimensions in this subject or topic. Building information modeling, BIM, is an intelligent 3D model-based approach that gives engineering and construction professionals the insights and tools to more efficiently plan, design, and build highway and bridge. The days of sharing documents via copy plan, sets, and files from silo to silo through an asset's life are diminishing. With BIM, all project data from planning to the commissioning is shared electronically with ready access for all involved in the planning, building, and maintenance process, providing more efficient data exchange. We can view here a small map of communication between reality 3D reality capture in the field and all the process of modelization and 3D plan for BIM for infrastructure. There is many road to modelize the BIM building information modeling or SimCity information modeling for many results. But an important point in BIM is that it can be used in the upstream phase of construction, but also for the renovation of dilapidated buildings. We can build before building or renovate before renovating. Chapter 2, to arouse interest. Now, this chapter is to stimulate your interest. To do the process BIM, business software must therefore be more collaborative and interoperable and require standardized technical data to feed this software in terms of structuring formats exchange protocol. The first objective in therefore to be able to have an interactive model, making it possible to stimulate various scenarios of the behavior of the building according to this or that parameter, environmental or energy, for example. Streamline exchanges between project stakeholders. Better design, build better, renovate better, better exploit, reduce costs and lead times, commitment of all actors from the start, better understanding of the project, better site organization, detection of problems, poorly negotiate business interference, cost optimization, reduce the operating costs of structure and their entire lifespan, data centralization, facilitate multi-year programming. This pie chart, I'm sorry, this is in French language, but this pie chart makes it possible to visualize the distribution of the cost of construction over a period of 50 years. We can clearly see that the costs related to maintenance and operation are around 75% of the overall cost. So we can now understand that the project owner must have a digital tool to facilitate the operation and maintenance phase. And that is the strength of BIM.
Mr. Faisal, can
Yes.
we interrupt you? Can you? Is it
Yes.
possible or not?
Yes, yes.
Can you go back to this slide, please? So here, the pie chart, you have construction 27%, and all the other parts of the pie are the parts of renovating, of exploitation of the building. Is it true?
It's true, because in this is an example from France, and we can see in the period of 50 years after the study and plan, the construction and exploitation and conception are only 2% to the cost of the construction in the 50 years, but energy, gross, the maintenance and exploitation is in the around 60 and 70% of the cost. That is a very relevant observation because now the project owner is the parts have a very good interest for BIM apply in the process.
So the time dimension is very important in BIM. This is
Exactly.
important, and it differs from other concepts and softwares.
Exactly.
Okay?
And
Thank you.
a big cost from maintenance and exploitation needs to have a very good data and 3D maps and plan for optimization all the costs.
And we also see that 30% are for the renewal of the building. 30% for the renovation of the building costs 30% during the 50 years. Okay.
Exactly.
Thank you.
Thank you too. And now we can take the topic of the BIM 3D model. The digital model is a digital representation of the physical and functional characteristic of the building or its infrastructure. Unlike a simple 3D representation, the digital model allows, thanks to a minimum of information on the object, represents and their presence and their properties, to be able to analyze or simulate certain behaviors, mechanical behaviors, stability, energy, performance, environmental impact, etc. Whatever its formats and the software used, a digital model can only be qualified as a BIM model on the condition that is object query intelligence. Unlike a simple DID 3D model such as a physical polystyrene model that only represents a tangle of volumes, the digital model queries that data. These data are of various kinds. First, composition, nature of the materials composing the drawn object. This is an example for a wall. Properties, thermal resistance, acoustic or mechanical performance, location, room name, buildings, object coordinates, etc. Semantics, item description, data sheets, links to manufacturers' websites. Here we show the relation between the manufacturers and manufacturing plants and the construction companies. Quantitative, volumes, area, length, and any other quantity associated with the constituent of the drawn object. Behavioral, behavior of objects between them. Example, a gable wall is attached to a roof, so that by moving the roof, the wall follows the movement. Mechanical, definition of the carrier nature or not of the materials used and management of the mechanical junction between the elements by assigning connection priorities. BIM is a tool allows you to unite the different professions around an ultimate objective. BIM represents a solution of the present for problems of the past and the future. Dimensions of the BIM. In BIM process, we can have many dimensions: 3D, 4D, 5D, 6D, 7D, and XD. For the professionals, 3D is regarding 3D laser scanning, CAD modeling and design, visualization in 3D, clash detection, and 3D printing. But 4D is regarding time. It's about project patient simulation, project scheduling, plan of resource payment scheduling. 5D is regarding estimating and cost, quantity extraction to support detailed cost estimates, quantity in defined position, multi-phased cost estimation, value analyze, change management. 6D is regarding sustainability, conceptual energy analyze, detailed energy analyze, sustainable elements tracking, lead tracking. We can also speak about facility management in 7D because it is an ultimate objective of the project owner for a life cycle BIM strategy, BIM as built, BIM embedded manuals, cost estimation, value analyze, and change management. But it is very important now to take the subject of sustainability in 6D. Shifting the focus to better understand the whole life costs of assets, where most money is proportionally spent, should make for better decision upfront in terms of both cost and sustainability. This is where 6D BIM comes in. 6D BIM is also referred to as Integrate BIM or iBIM. It includes the information that is required to support facility management and operation to drive better business outcomes. This data includes information such as the manufacture of components, its installation date, required maintenance, and details of how the item should be configured and operates of optimal performance, energy performance, along with lifespan and decommissioning that data, facilitating and different kinds of components to the BIM model enables decision making during the design process. In effect, designers can explore a whole range of permutation across the life cycle of a built asset and quickly get an understanding of impacts, including costs. However, it is at handover that this kind of information really adds value as it's passed on to the end user. 6D BIM model offers an easily accessible and understood way of exporting information various details that would have gone annotated in paper files are now easily integrated graphically. And now for understand more about the topic and the subject, we must speak about urbanization, about urban agriculture. Urbanization is transforming human societies in many ways. Besides bringing benefits to people in cities, it also has negative impacts such as food security. One way to meet the challenge is urban agriculture. However, traditional agriculture practices are not suitable within urban areas due to the limited availability of land. Therefore, the alternative option is to grow crops inside or on top of buildings. Building integrates agriculture, BIA, but there is limited research and information available for designers and planners to design such buildings. We need to bridge the gap between agriculture and architecture by proposing a building integrates agriculture information modeling tool in integration with building information modeling, BIM. The plugin tool has data on plants requirements and automatic response to environmental factors. Environmental factors include temperature, light, water, nutrients, air, humidity, spacing, and support. In US Environmental Protection Agency, the urban agriculture is the part of a local food system where food is produced within an urban area and marketed to consumer within that area. Urban farming can also include animal husbandry, breeding and raising livestock, beekeeping, aquaculture also, aquaponics, and non-food products such as producing seeds, cultivating seedlings, and growing flowers. Urban farms can also contribute to the revitalization of abandoned or underutilized urban land, social and economic benefits to urban communities, and beneficial impact on the urban landscape. Now, I share with you a video from the experience of Singapore in the BIA, the Building Intelligence Agriculture.
There is no music there, Faisal? Mr. Faisal, is there any music?
Yes, you cannot.
No, we don't. We don't hear any music.
Okay, it's just. Partage. It's maybe.
I think it's because you have the
issues.
headphones. Yeah, you have the headphones. You're the only one who's hearing the music, I think.
Yes, I try to. Ok, c'est diffusé en direct. J'ai compris.
Perhaps you need to disconnect your headphones.
Okay. I try again. It's okay?
No.
Okay.
Mr. Mohammed Warani says that you need to share the computer sound. This is an advanced sharing option in the sharing screen. When you go to sharing screen, you need to share the computer sound.
Okay.
This is the Singapore that we all know. It's futuristic, green, and home to some of our world's most impressive buildings, from airports to hotels and even floating Apple stores. But there's one thing you won't really find here. Farmland. Singapore currently imports 90% of its food supply. That means when something like, say, a global pandemic or geopolitical tensions disrupt the supply chain, being able to produce your own food within your own borders suddenly becomes really important. To make its food supply more resilient, the Singaporean government has laid out an ambitious goal: produce 30% of its own food by 2030. But unused land in Singapore is hard to come by, so urban farms are popping up inside, outside, and everywhere in between. As the world's urban population continues to grow, these might just be the farms of the future, and construction will need to know how to build them. Today, Singapore's population is 100% urbanised, and traditional farmland makes up just 1% of the city's landmass. But it hasn't always been this way. Agriculture's never been a huge part of Singapore's economy. In the 1960s, it accounted for around 4% of GDP. But as Singapore continued to invest in urban development, economic focus shifted away from farming and towards manufacturing. And by the early 2000s, agriculture's role in Singapore's economy was almost non-existent.
We have lost probably generations of knowledge and also participation in food production in our country. So I wanted to see what I could do to sort of reignite that a little bit.
That's Bjorn Low, a digital marketer turned urban farmer who co-founded Edible Garden City.
We have built 260 edible gardens in Singapore, whether it's for homes, hotels, restaurants, on top of shopping malls, in schools, and then in a lot of various underutilized land around the city.
Over the last decade, Bjorn has seen the sector shift from being led by smaller farmers like himself to getting major government and industry investment.
So you have a lot of big commercial players coming in, whether it's from the fish farms or the egg farms. You have technology providers coming from Holland, from Japan, wanting to use Singapore as a platform, as a launch pad for their technology. It has become a well-oiled ecosystem, or almost an ecosystem at this point.
In a sense, the groundwork has already been laid for edible landscaping in Singapore thanks to a 2009 city planning policy called LUSH, which stands for Landscaping for Urban Spaces and High-Rises. It requires developers to incorporate greenery into their plans and has helped give rise to a massive landscaping industry in the city. In 2017, LUSH was updated to include a provision that allowed rooftop farms to count towards the required landscape replacement area of a building. Now, with the government's 30 by 30 push to produce more of its own food, urban farming is looking like it could have its own renaissance, building quite literally on top of the success of LUSH.
So Singapore is looking at a strategy of increasing production from that 1% of land through technology approaches, whether it's building vertical farms, factory indoor farms, battery farm production systems for eggs, and intensive aquaculture systems.
Right now and to some degree you're right, indoor farming is part of Singapore's plan. Artisan Green grows spinach in a controlled indoor environment using water instead of soil and pesticides. Everything from the light to the temperature can be optimised for the specific crops. Sky Greens uses hydraulic power to rotate and irrigate crops in modular vertical frames. The racks can be stacked up to 9 metres and housed in outdoor greenhouses. But while controlled environments can help avoid some of the pitfalls of traditional farming, like water pollution caused by pesticide runoff, the process can be quite energy intensive. And after labour, energy and technology costs, it can be hard for urban farmers to compete with the price of imports.
We know that the food system is challenged because of the approaches of industrialized production. By creating controlled environment agriculture, warehouses of plant factories, for example, we're falling back into the same space. So whilst we have that as one approach, which is highly publicized and focused on, we need alternative approach to that.
One alternative to growing crops inside buildings is to simply build farms on top of them. In partnership with the Singapore Food Agency, City Ponics opened a pilot commercial farm on the rooftop of a multi-storey car park, where it grows lettuce, spinach and basil, or basil if you're watching in the US, using its hydroponic vertical farming racks. And Edible Garden City has designed urban farms to live on top of shopping malls, car parks, and even in an unused outdoor jacuzzi. The government's making more space available for larger scale farms too. Since 2020, it's offered up to at least 16 car park rooftop sites to be rented out for 3 years as urban farms. In addition to contributing to the 30 by 30 goal, the government said urban farms can also help to cool the city through rooftop greenery. Design firms are also looking to the urban island as they think about the future of sustainable design. Gensler's come up with ideas to incorporate farming solutions into park benches, building facades and even ceilings. And Arup visited Singapore back in 2019 to explore the future of urban agriculture. But when it comes to urban farming, going from concept to construction is only half the battle. The biggest challenge of all may be getting people to actually eat the food, especially when it comes with a higher price tag.
It really requires everyone to participate in it. Right, whether it is growing that leafy greens at home and understanding that process, or then starting community farms within, their HDB blocks to drive a community effort to food growing. I think that is really important, because we may never hit the 30 by 30 if we don't have a whole society approach, because industry can only do that much, government can only do that much, so everyone needs to participate.
Singapore isn't the first to turn to urban farming. In the 1990s, Cuba began building its own urban farming infrastructure out of necessity because of the collapse of the Soviet Union, which led the country to lose roughly half of its oil imports. And today, cities including Sao Paulo, Seoul and Tokyo all have their own urban farming initiatives. What makes Singapore unique is that it's essentially building an agriculture industry from the ground up.
What if we can develop and maintain a purposeful landscape or edible landscape? And if we can start to build a landscape nutritional index, instead of how much greenery there is, we can start to count how much carbohydrates there is in this given development, how much protein are we producing from the root vegetables or the moringa tree, the leaves are high in protein. It can become a latent food bank to build a layer of resiliency for the state. And that potentially can get us to hitting the 30% by 2030.
Right now, Singapore is a kind of test case for modern-day urban farming. If it takes off, then it could serve as a blueprint for how we build the food-resilient cities of the future. But only if everyone gets on board. If this video is growing on you and you want to learn more about where construction is headed, make sure you're subscribed to Tomorrow's Build.
Mr. Faisal, we have lost you. Mr. Faisal, we have lost you.
You can hear me now?
Yes.
Yes.
Perfect. Perfect. Okay. It is a relevant video that presents the add value of urban agriculture in a small territory in terms of technical strategy and sovereignty. Building integrating agriculture, BIA, is a new paradigm in urban areas, is claimed to be environmentally sustainable vis-a-vis conventional commercial agriculture practices by reducing food miles, minimizing land and water use, and improving yields. However, as it is operated in controlled indoor environment, BIA can be highly energy intensive. In order to be better understand the influence of local food sheet characteristics, climates, conditions, and farms properties on the environmental performance of BIA systems, this presentation apply a performance-based parametric simulation workflow for BIA that incorporates daylight, energy, crop growth, and water models to rooftop greenhouse farms and shipping containers farms located in the city of Lisbon, Singapore, Paris, and New York. Results show that while RG farms, it's roof farms, can significantly reduce GHG emission and all the testing climates. Okay. This is regarding a paper from research by Khadija Bennis, Christophe Reinhardt, and Paulo Ferrao. It is a case studies and simulation inputs from 4 cities, Lisbon and New York, Paris, and one more. It's regarding a potential of mitigation environmental impact of food production depends on specific condition of a given urban food system, on the level of technology and efficiency of the existing cultivation facilities, and on the transportation mode and distance traveled by the crop to reach the city. The above described BIA simulation workflow was applied to hypothetical urban farms with hydroponic tomato production and assessed against conventional tomato supply chains of 4 metropolitan areas, Lisbon, Singapore, Paris, and New York, to shed light on the extent to which higher yields and lower transportation distance can offset operational and transportation-related energy use intensity of BIA across climate, condition, and metropolitan scales. Tomato was selected here as a corp due to the vast existing literature about controlled environment, soilless production of tomato, and to the availability of data and fresh tomato supply chain for the 4 investigate metropolitan area. This is a table, the results of this research for the 3 cities. But what is important here, it is important to show the workflow that be used by the
Mr. Faisal,
yes.
can I, please, could you mask this small window? Tu peux appuyer sur masquer, le petit truc là. Il y a arrêter le partage, il y a masquer. Tu peux, voilà, merci.
Perfect. Okay, this is the table results from the research of Dr. Khadija Bennis. And we can see here the the parameters for 4 cities around the world. But it is very important to have an idea about the workflow, because here we have 2 topics. We have BIA, it's a Building Integrated Agriculture, and we have also BIM, Building Information Modeling. The workflow used by Dr. Khadija Benis is regarding the orientation of the buildings or container in these 4 cities. It's about geometry, very important, altitude, orientation, footprints, and height in meters. Also, we have materials of the building, like steel or aluminium, supplemental lights, if we have supplemental lights, and climate control, and climate crop for tomato, with also hydric stress in LIA parameter. The workflow used is in relation with Reno. It's a big software, Reno City. It's a software that allows us the possibility to do simulation for orientation of the buildings, and have a simulation for the speed of wind, and also have some control operation with the ventilation, climate, energy, and many more characteristics. We have here an overlap between BIM and BIA. We have 4 points. BIM can be the best way to carry out simulation in relation to the orientation of buildings at the scale of a city, of the optimal choice in terms of sunshine and wind. BIM makes it possible to better understand supply chains in terms of transportation and commercial way. BIM allows, among other things, and thanks to 3D reality capture tools, to achieve a better estimate of performance. The BIM, and thanks to its extension towards the infrastructures, make it possible to better analyze the relevance of the hydraulic structures, and in particular for the needs of irrigation. Just for info, this paper is in Google. You can share it, or you can upload it from Google. It's a Building Integrated Agriculture BII in urban context. It is a very relevant paper. Any question in this topic? Mr. Wariti?
Yes, if we want, I think we have to take a little break to have questions and answer sequence. I have a comment about what we have seen up to now. It's a very, very innovative thing. So we need time to digest all the information that we have at this time, because it overlaps a lot of concepts, a lot of tools, and we couldn't imagine what will it be. So before we start this session, so everybody is welcome to share his comments or feedbacks or questions for the first part of this session. I have a question. So building information agriculture is a concept that uses BIM as a concept tool. Is that right?
Exactly, because here we need an input to do some simulation. And with the BIM, building information modeling, or with its cousin SIM, city information modeling, we can have all the data, geographic data and semantic data to do some simulation. If you know, we have a very good softwares like InfraWorks from Autodesk, or Skyline, or RenoCity. There are a very big software to do simulation in terms of temperature, in exposition, wind, and many more characteristic. And BIA needs this simulation to have a good input to looking for a best location to do the rooftop agriculture, or any idea with the container, or in rooftop building.
Let's check if there are some questions. Not yet.
Assalamu alaikum. Hi, how are you?
Yes, we have Mr. Mahmoud Al Khulaifi.
Yes.
Go ahead.
I think the
From
question
which country?
To you, from Iraq. I am from Iraq. My question to you, Dr. I think I mean your name. Yesterday you have present about culture before the lectures or the course training start, and your presentation which the culture and which supported by many organizations about water scarcity. Why this organization work, for example, not in Iraq? I think in Iraq, political instability after you can do for Iraq, but for example, for Sudan or Egypt, you should work this organization in this area, because I think the food security in this area, not only in this area, around the world, especially with Sudan area. This is my question. Why all this organization you presented in your lecture before yesterday, before the course training start, and you present all this organization?
Okay, thank you, Mr. Mahmoud, for your question and your interest about culture water. So culture water is new, is a new business unit within culture. So our aim is to work in Africa to build, but to just give advice to investors, to governments, in order to build water infrastructures that are bankable, that can be financed by banks, by investors, and also with subsidies from the government. Our aim is to be facilitators, because we have noticed that within the value chain of water infrastructure, there is a gap. So we have governments that are working toward building infrastructure. They take finances from the World Bank, from the IMF, and so on. You have some agriculture and association of agricultures that need irrigation, but they don't know how to design a project and present it to investors. And you have investors that are looking for projects, but they don't know where to go and how to get this project to invest in. You have also operators that run the facilities that they have the know-how, they have the expertise, but they need to know that there is a project somewhere and they to go there. So we can talk to everybody because we know the needs of the finance people, we know the needs of citizens, agricultures, we know the needs of operators, and we know the needs of the government. So we have this expertise. Now we are focusing on Morocco to get more marketing for us. And once we are well known in Morocco, we are going, the next step is to go to other countries. But if somebody call us to go to Sudan and work with them, we are ready to do it right now. So welcome to everybody to ask us for help if there is a project that need finance, that need design. We are not a consulting firm, a design firm. We don't design plans, but we design projects, and the whole concept for a project to be good for everybody.
Hello, sir.
Okay.
Good evening.
Thank you, Mr. Dr. Amin. Thank you.
Good evening.
Hello, Mr.
Good evening, Dr. Selvarasu.
From
Good evening.
From India.
Yes, yes.
Okay.
Dr. Selvarasu, I ask one question. In Morocco, what about the storage of water capacity, such like dams and storage of ponds? Any facilities available in your country?
Is the question
the capacity
for
of
Mr.
them?
Faisal? Is the question for Mr. Faisal Adlouni?
Yes.
So can you repeat it? Faisal, have you understood the question? I didn't understand.
It's 18
Not yet.
million cubic.
Can you repeat the question, Dr. Selvarasu?
Yes, yes. In this capacity to storage of water in Morocco.
It's regarding the hydraulic infrastructure.
Yes.
What is the question? Is what is the capacity of storage of water in Morocco?
Yes.
I'm not the specialist in this topic, but Mr. Wariti maybe can give us some answers.
So this is Dr. This is Professor Ismail who is talking right now. So he will be the lecturer of tomorrow in for the topic of smart farming. Thank you, Mr. Ismail, for giving help today. So I think either Mr. Faisal nor myself can answer this question because we don't have the figures now. Sorry.
Yes.
Can you hear me?
Perhaps Mr. Mohammed Adwani is here with us. Can you? The question is the usage of water per day per person in our country. So we have those figures yesterday.
Dr. Amin?
Yes.
Really?
We have it yesterday from the presentation of yesterday. So I think we can keep on, Mr. Faisal, on your very important and interesting presentation.
Okay, just for this chapter, we have a small exercise for all the participants. Here we invite you to do a little reflection on what BIM can be beneficial for the BIA through a SWOT analysis. It's regarding strengths, weakness, opportunities, and threat. We know that all in this all among our training and presentation are
Hello?
not professional in.
इसको खत्म है ना?
Hello?
फेयरवेल है ना? मतलब जहाँ
Go ahead, Mr. Faisal. Go ahead.
Okay. I repeat, we invite you to do a little reflection on that beam can be beneficial for the BIA through a SWOT analysis. And this reflection can give us a small idea about the relevant points between BIM and BIA. Are you ready?
Yes.
Okay, we can have 5 minutes to do this exercise.
Okay.
Okay.
And after we exchange the idea in chat or in talk with all the hots. Mr. Warity?
Yes, I'm here with you. So it's okay. So we'll have 5 minutes to reflect on this question.
It's just about a matrix, strengths and weakness are internal about the BIM and the BIA, and opportunity and threats are external.
Okay, fine.
Hello, no sound here.
Hello.
Hello.
Yes, there is no sound because we are now reflecting on this question, Mr. Mr. Bonwell, okay?
Thank you.
We have a question to reflect on. We have some minutes of reflection. So can somebody share with us his reflection on this question? Is somebody ready to share with us his reflection on this question?
Hello, good afternoon. I am Anjali from Mauritius. Can you hear me?
Good afternoon. Good afternoon.
Yes, we can. Thank
Good
you.
afternoon, yes. So I've tried to work on this. In my opinion, the strength for this for the SWOT analysis, maybe there is a decrease in the production, in the cost of production.
Mm-hmm.
For the harmful, maybe the use of there may be how do I say it? It's the current some companies may not have the financial means to implement this project.
Mm-hmm.
And the opportunities, as you have said, we can have trainings on this to implement in our country. And also, and the threat is, I don't know, maybe the use of some pesticides or I just it's just one of maybe the use of pesticides to implement the project.
Mm-hmm.
Okay. Thank you.
Excellent.
Okay, to summarize, I didn't hear all what you said, but what I hear is one of the drawbacks could be the financial means, and one of the opportunities could be training.
Yes.
And one of the drawbacks could be also be pesticides.
Yeah, yeah.
And the first thing you said is production.
Yeah, there may be a reduction in the cost of production.
Reduction in the cost of production. Okay, thank you.
Okay.
Any other participants who want to share with us his thoughts about the subject? Okay, perhaps Mr. Faisal, can I share with you my thoughts on the subject?
Yes, yes.
Okay, thank you. So, what I found are only positive and opportunities or strengths. So we have what would be helpful is that we can assess the opportunity of urban agriculture in an area based on the reference line, which is the climate impact of current food supply in a given city. The second thing is build an efficient infrastructure for urban agriculture within a city and within a building.
Yes.
So when we have assessed the opportunity and we find that if it is good for us to create urban agriculture, to create the project, we need BIM to build an efficient infrastructure for that, especially for irrigation pipes.
Exactly.
And we have another opportunity, which is an externality, like economists like to say, positive externality. It could be an incentive to model a city and rethink the occupation of soil and urban planning.
Exact. Excellent. Mr. Warisi?
We have Enyetu Joshua that says that strength, it is helpful in planning infrastructure and so avoid errors or reduce time for construction. We have another person who wants to say something, I think. Okay, so go ahead, Mr.
Perfect. Perfect. We can add in terms of weakness, the irrelevant 3D data in the case when we have not the good technology to capture the reality. But now we are sure that with the satellites, drones, oblique photos, and mobile mapping system, we can have a very good quality of data in 3D. Another opportunity I can add is regarding many countries seek food independence, but with a small territory like Singapore. And in this case, they can use the 3D modelization to choose the best place to have a urban agriculture with a relevant workflow mixed by BIM and BIA. Another strength is the big benefits for simulation with BIM and SIM, City Information Modeling, when we have all the inputs and we have relevant data. And finally, in threads, I can talk about the sovereignty and the propriety of data, because all the 3D data is regarding sovereignty. Then some countries like Morocco don't choose to download or upload the data in a cloud. Then we must have a big servers or desktop softwares to do that. Some countries in all over the world that don't have this threat, but it's specific to some countries. That's all.
We have Mr. Enyetu Joshua, who said that what could be a weakness is that he thinks it requires also a lot of time for learning.
But learning is an investment.
Yeah, but it's a weakness. It's not easy.
Exactly.
Fine.
Any more add or remarks?
No, you can keep on, please.
Okay. My presentation is finished, but I want to open the discussion with you to have some questions or some remarks about this topic. Please, have you any question?
Oh, okay. Thank you, Mr. Faisal Adlouni, for this very sound and exciting and innovative topic that you have chosen, because it makes us reflect on something very new, and it's not used largely in the world. So we are thankful for that you have shared with us your insight on this topic. What I'd like to do is the link between all the training sessions that we have done so far, from the first day to this third day. So in the first day, we have been thinking about the governance of water, the governance of integrated water management, the example of Morocco. And we've noticed that this governance is very important to have data for hydrological modeling. So in the second day, we have been through hydrological modeling, which needs a lot of data. And if we don't have a good governance of this sector, we won't have the good data to do modeling. And we've seen two softwares. One is ArcGIS, which is the platform, the software platform that uses SWOT model to modelize hydrology. And it's for large area, bigger than a city. And now we have focused on buildings and also cities. So how to model city and a building, and we can add lots of parameters like climate, wind, how we say it, l'ensoleillement, etc. A lot of parameters to model agriculture within a city. So there is a link between all those sessions. It's about modeling physical world. It's all about modeling physical world and incorporating natural parameters within the model. So there are many ways to model the world, many ways, many softwares, many concepts. And each time we add a new layer. So within BIM, it was first for modeling just a building, the walls, the structure, the water, the light, etc. Then it's extended to infrastructure within the city, and now it is extending towards agriculture within a city, which need more parameters and other models.
Exactly, Mr. Warity. It is a big opportunity to share with us all this information regarding water, buildings, interaction between the earth and all the industry. This is very relevant topics. Thank you for my part.
What I would like to add also is that the aim of all modeling is to understand the world, and understanding our world is important to adapt to climate change. If we cannot model, we cannot foresee the future. And if we cannot foresee the future, we cannot take action today toward this future to adapt to this climate change. So modeling tools is very important and is a very strategic skill that in every country should aim to enhance and to promote modeling techniques, modeling skills within its researchers, its engineers, its government bodies. Because decision making lays upon the modeling capacities of a country.
Exactly. Just in the topic of 3D modeling, I can share you some experience that I have in some territories, like in south of Europe and also in North Africa. We remarked that 3D reality capture solutions like LiDAR and aerial acquisition and also mobile mapping system in this region give us the input for have the 3D models and for accuracy and exhaustive models for our cities, our territories, and our farms. This is very important also to share with you the engagement of some governments and some banks, world banks, in financing a project with the DNA of 3D reality capture, especially in West Africa. Now we have a big project in Congo, in Ivory Coast, and also in Senegal. This project is the mixed between propriety and territory and 3D modeling. And this is very important to have a very accuracy model to have a good decision. This is very important. Thanks. Any question regarding BIM or BIA?
I have a question about BIA. Is it a software layer on BIM, or is it just a concept?
In my opinion, it's just a concept who consume the data from BIM, but it's a dimension of BIM. Okay, we can talk about 6D dimension and 7D for exploitation and maintenance, but also BIA it's another dimension, because BIA have to analyze the data from geometry and from exposition and from the city model. Then BIM can give us this input to have a good idea and to have accuracy model. Then, in my opinion, it's a dimension.
It's a dimension. And what about the formulas to model the parameters? Are they already incorporated within the softwares, or the modeler should write his formulas of modeling all these parameters?
The parameters in terms of sensors can be collected in the field, because when we talk about twin or digital twin or avatar of the city, this is just a passive avatar. But if we add sensors like temperature sensors and acoustic sensors in the avatar, we have in this moment active digital twin or active avatar. Then we can have a data in real time, accurate data, and mix it with the 3D. This is very important to know.
Okay. Please feel free to give us your thoughts, your comments. Share with us your experience in your own country, how you see urban agriculture can be important for your country, for the development of your city and your country.
I have just a remarks. Mr. Mohal Ayashi, are you here? If not, it's not a problem, because Mr. Mohal Ayashi is an expert in 3D, in modeling, and also in real estate, and he can give us some observation or remarks regarding this subject. Okay, we have a question from Mohammed Ahmed Eid. BIM is similar to AutoCAD software. No, BIM is not a software. In the first slides in my presentation, I talk about the process BIM. It is a new paradigm. BIM use software like 3D software, Revit, Tekla, BIM Vision, or another software existing, but BIM is not a software. We use the software in this process. Mr. Ismail? You can make your own architecture depending on your own needs. Exactly. This is in terms of conception, but also we have a BIM in as-built phases. Then we can have a building, and we can scan it with the 3D reality capture solution and do a model BIM as built in as built phase, not in conception phase. Mr. Ahmed Mohammed Taha, can you share the link to software download? Mr. Mohammed Taha, in the topic of BIM, we have two family. We have the open BIM and we have a closed BIM. In terms of open BIM, you can download software like Beam Vision and Solibri. There is open beam softwares like QGIS for GIS, and yes, Beam Vision for opening the EFC model. And in terms of closed beam, you have the big family of Autodesk, Revit, InfraWorks, Navisworks, and all the family. Autodesk is a big company. They develop many softwares, but it's not free softwares. Okay. We have a question from Hind Mustaid. Outside dams, how can we use BIM in agriculture? In terms of agriculture, we have an infrastructure, extra infrastructure, like Mr. Wariti, Chateau d'eau.
Like water storage reservoirs?
Yes, storage reservoirs and irrigation systems. We can use BIM to model this infrastructure, and then have a 3D model BIM oriented to do simulation and to add some layers like orthophotos or 3D point cloud, 3D models. That's all. We have another question from Ismail. We can use it in the hydro agriculture structure. No, it's just a remark.
So the importance of BIM is that we can, as in GIS, is that we can add many layers. So when we are studying a large scale region, we can add layers of transportation, layers of piping, electricity, building, and everything could be added in the same system and modeled. This is the importance. And what is also important is this model is used in the whole life cycle of the project, of the region, of all the infrastructure, all the maintenance, the costs, and also it is shared within all the shareholders. All the stakeholders share the same information within the system, and they have access to use it. This is what is important, is the concept of sharing information between hydrologist, structural engineer, planner, and government bodies. Everybody is within the system, and he can add his information.
Exactly. The add value of the BIM process is the collaboration and participative approach. Then when we use BIM process in buildings or in renovation, we are sure that we have a very relevant process and good workflow, digital workflow to share, to communicate better with all stakeholders, and we can need the BIM process in agriculture, in urbanism, in government, the government démarche, or in statistics. All the studies can be piloted by BIM, especially the study with the DNA oriented to location and geolocalization.
When we compare BIM concept to GIS, I think it's more comprehensive. Is that true?
Exactly. Yes, because we have many similitudes between GIS and BIM, and many research oriented now to the overlap between GIS, 3D GIS, and city information modeling, who is the cousin of the BIM. Why? Because they are two process. Different interoperability environments, but with the big similitude. Why? Because in GIS 3D, we are oriented on space. We have to model the city, maybe the territory, the department, and we have a data georeferenced. What is the plus in the BIM process? The plus is the semantic data, and also the process who can give us the economic and financial data to resolve some problems. And also with BIM, we have some orientation from civil engineering and architecture. But in GIS, we are in geomatics area, in geomatics ecosystem. It is a special environment of specialists. Okay, BIM is more open, is more collaborative, and we can have some more interoperability because the community is very big than GIS. For Mr. Mohammed Ahmed Eid, the question is regarding the SWOT analyze. We put the SWOT analyze in this training. Why? Because we need to search your idea, to challenge your reflection, and to have an interaction between the hosts and the participants. Just all.
Okay, so I think we have done a good job today with Mr. Faisal Al-Ajlouni and all the participants. It was very interactive today, and it's important to have this interactivity. Thank you, Mr. Faisal, for sharing with us your enthusiasm about new technologies, about BIM, about building information, BIA, agriculture, about all those new concepts. And we have a long time forward to grab all those concepts and learn and train in those new skills. So thank you to all the participants for being with us today. So our rendezvous is tomorrow at the same time. It's 8:30 GMT. So I hope you will be with us in numbers. And I see you. Goodbye. The floor is yours, Faisal, for thanks.
Goodbye and good luck. Thank you for your presentation, and thank you for your have patience with us to answer our question. Thank you for everyone. See you tomorrow.
Goodbye. See you.
Bye.
Thank you. Bye.
Thank you all.
Faisal, last word.
Thank you. Bye.